we're going to be focusing on adding dividing decimals. So before we can add dividing decimals, we need to add 2 more vocabulary words. So that's going to give us 5 total words for this next test. That's it, just 5. And after today, you will have all of them. I want to review real quick the vocabulary words that we had last week. Raise your hand if you can tell me. What tells you the location of a digit in a number? What tells you where a digit is located in a number? Logan? Place value. So that's one of our vocabulary words. What is a process to do calculations? What is a process to do calculations? Dylan? Algorithm. Sorry, I choked on my own don't stop. Okay. All right. Algorithm. Yes. Very good. Got me a little choked up there, Dylan. All right. What is a number with a point separating the part larger than 1 and the part smaller than 1? Tanner?
Decimal.
A decimal. All right. Remember, a number with a point, we know that's a decimal, but adding that explanation of that point is separating the big part and the little part, sometimes that little explanation throws us off. So a number with a point is a decimal. That decimal separates the part that's bigger than 1 and the part that's smaller than 1 than a whole number. All right. Those are the vocabulary words so far, so let's add some more. The first word is a terminating decimal. Now the word terminate. All right, that should sound like something that we know, all right? I know we have a terminator that comes to our house to spray because I have a crazy, insane fear of bugs. Do not let them in my house. Get them away from me. So the word terminate, guys, that means we're ending. We're stopping the bugs from coming in Miss Sawyer's house. All right? The word terminate, raise your hand if you can give me another definition for terminate. Luke?
Tonight we have to terminate the other team.
Tonight, our football team wants to terminate Homewood, right? Isn't that who we're playing tonight? All right, so y'all want to stop them. Y'all would like to stop them from scoring any points because I hear so far no one has scored on y'all.
Nope.
That is amazing. All right, so the word terminating, guys, it just means to end something. All right, raise your hand if you've heard of the movie The Terminator. All right, with Arnold Schwarzenegger. All right, that was that's my best impression. All right, I don't do impressions. Okay, y'all can tell now why. All right, so the Terminator, guys, his goal was to stop the other robot things, right? Yeah. Robot alien cyborgs. Thank you. I would have never filled that in by myself. Logan?
Speaking of termination, we're trying to get spray for wasps that keep on invading my house, basically.
Oh, yeah.
Guess what I see on every day at my house?
Wasps.
This is just a whole row of just wasps.
Yes. So that's definitely something that you want to terminate. So Logan wants to terminate the wasp at his house because those are even scarier than normal bugs, okay? So, that's awful. All right, so the word terminating, we're getting the word terminating means to stop something from happening, to end something. Same thing with decimal, guys. A terminating decimal is a decimal whose division you know where the pencil sharpener is, whose division ends. All right, so a terminating decimal is a decimal whose division ends. Basically, guys, a terminating decimal is a decimal that stops. So here's an example of a terminating decimal. Listen closely. 5.8. It's a terminating decimal. Did it go on forever and ever? No, it stopped. 9.786. Terminating decimal because it stops. 0.9111. Terminating decimal because it stopped. Luke?
But if it was
If it kept going, then it would not be terminating, and that's probably what we're about to look at. All right? So, shh. I need us to listen, please. Diesel, I need a space in the front, please. right, so a decimal whose division ends. Now, guys, we're specifically adding this when we talk about division because a terminating decimal happens when that division stops. All right? The reason that it's specific to division is because every single number that you add, can you add numbers that go on forever and ever and ever and ever? No, because you'd be adding forever and ever and ever and ever. So any number that you're adding is terminating. Any number that you're subtracting is terminating. Any number that you're multiplying is terminating because they're already going to stop. On division, it might not end right away. It might not end at all. So we're going to talk about that, what's going to happen there. All right? Some of us might not even realize all these decimals that we're working with come from division. So, for example, if I have 36 divided by 24, all right? It didn't go in perfectly, but it gave me 1.5. That's where I got that decimal because it didn't go in perfectly. All right, we've been writing our remainders as fractions, right? With decimals, if you have something left over, we can't write it as a fraction. My rule for that, guys, if we have decimals, numbers that are decimals, we have numbers that are fractions. Those are hard enough without putting them together, don't y'all agree? Like, we need for fractions to say on their fraction planet, decimals to say on their decimal planet, because if they, got together, guys, they would, take over the earth and ruin math and everything on earth. They would,
Yay.
Earth would be gone, okay? So we need to keep our decimals and our fractions separate. If I had a number like 8 divided by 9. Now here, what's happened, y'all see my decimal that I got here? Can y'all see that? All right? So this is kind of like what I think Luke was saying. Now, this calculator stops. Is there any more room in this calculator for it to keep going? No. Do you think this number just magically stopped? No. The calculator just ran out of space, right? So we're going to look and see what that's going to look like in our work today. All right? So what we just saw is something called a repeating decimal. A repeating decimal is a decimal whose digits repeat in groups of 1 or more. It's a decimal whose digits repeat in groups of 1 or more. So in what we just saw, it was an 8. It was 0.888888888. So in that case, was it repeating in a group of 1 or in a group of more than 1? It was just 1 because it was just that one digit, right? It was just the 8 that was repeating over and over and over again. Tanner?
I did something like that on my phone, and then whenever it ran out of space, I tilted it the other way, and it just grew more.
It gave you more numbers. So that's kind of cool. So I like what Tanner was saying. He did it on his phone, and he was holding his phone straight up like normal. And then when he turned it, on your phone, your calculator will turn, and it actually just added more numbers to it because it didn't stop. It kept going. One way the calculator didn't have as much room as the other way. That's cool, Tanner. Never tried that. All right. So here's some examples real quick. Some examples of some stuff that might look like. So, I might have 47.88888. Now, guys, in, the English language, if something continues, we would just put a ... Now, y'all know math is its own language, right? Have y'all ever realized that? Math is literally its own language, which... Yeah, every year teacher math is its own language. It's so unique to itself, and so much of the vocabulary, the word terminating, we know what the word terminating means in the real world, but then it also has a meaning in math. All right, it's kind of never mind. All right, sorry, train of thought that did not actually connect. So when I have this in the English, we might put ... But in math, we have another way of writing that. All right, the way we would write that in math would be 47.8. It's just the 8 that's repeating, correct? So I would put a line above the 8. Okay. Another example that you might see, you could see something like 0.7565656. So in this case, what is it that's repeating? the 5 and the 6. So when I write my answer, I would put 0.756. Am I going to put my line over that whole thing? No, just the 5 and the 6. We're going to be very careful, guys. You got to be careful with that 9. Don't get like sloppy and go throwing lines around. If I just did it real quick and put it over the whole thing, that would be wrong. Okay? Do we have any questions about those two definitions? All right, the spelling count on the test? Yes, please make sure you can spell those. They're pretty easy. Terminating, that's one of our longest words. It sounds like it spells, so that should be pretty easy. Let's talk about dividing decimals. Dividing decimals. Guys, this is just a reminder because when we divide decimals, for some reason, people get a little goofy when they set them up. The first number is the one that goes inside. I'm not going to tell you how many people today on their homework started working them, and then they came up to me and they were like, on number 1, I don't understand how to divide this. And I would look at their work and I would say, well, let's look at what the problem says. And they had put everything in the wrong location. All right? So let's be really careful with that. All right, so my number that comes first, that 46.32, is what's going to go on the inside of that division bar. All right, and then my 0.4 is what's going on the outside. All right, so let's make sure we're setting those up correctly. All right, so we got it set it up. Then step 2. Step 2 says the divisor, which is the number at the door. Now this just says divisor, right? Doesn't say anything about the dividend? No, it just says the divisor cannot have a decimal. That means we're in trouble because if I look at the door, we definitely have a decimal. So let's keep reading. It says the divisor cannot have a decimal. Then it says move to the right if needed. Well, we definitely are needed here. So we need to move this to the right. How many spaces over? 1. So that's going 1 space over to the right. Excellent job, guys. Now, if you look in these parentheses, and it kind of cut me off on the copy, it looks like, that says if you move the outside, then you have to move the inside too. So if you move outside, move the inside too. So how many times did I move it on the outside?
1.
Can I just make up and move it however many I want on the inside? No, it has to stay matching. It's kind of like with fractions. If I do it on the top, I have to do it to the bottom. If I do it to the outside, I have to do it to the inside. Guys, everything in math is all about staying balanced. All right? Everything in math is all about staying balanced. All right, so now I've got my decimals moved around. The last thing says raise the decimal in the dividend. So now we're talking about the dividend to the root. All right, that's where we take it from the inside and raise it up to the top. All right, so we're going to raise it to the root. This is my like dorky math move right here. Raise it up, okay? So we're going to raise it. Okay, so your parents will probably have heard the song, okay? The song that was like the roof is on fire. And everyone would raise the roof. That was the move that you did, okay? That was actually before my time. But it's just something that people know, or they did know. Apparently, it's really old now. Okay? So we're going to raise that decimal to the roof. Go home. Ask your parents if they know how to raise the roof. And they're going to do this. They won't make that face, but. All right. So we raised our decimal up to the roof. So now we're going to look, and we've got the 4 at the door. And we're just going to divide like normal. All right? So 4 will go into 4 how many times? 1, so I'm going to write a 1 on top. 1 times 4 is 4. When I subtract, I get 0. 0 is smaller than 4. I'm going to keep going. And I'm going to slow down. Alright, if this was a smaller number than 4, we would just move over and keep dividing like normal. This is just normal division algorithm. We're not doing anything special. We're going to bring down the 6. How many times will 4 go into 6? 1. So I'm going to put a 1 on top. 1 times 4 is 4. When I subtract, I get 2. We're going to bring down a 3. 4. How many times will 4 go into 23?
7.
5 times. 5 times is going to be better. 4 times 7 gives me 28, so that's a little bit big. I think you were thinking about 3. 5 times 4 is 20. When I subtract, I get 3. Now, guys, have you noticed when I put my numbers up on top, have I just put them wherever I wanted to? No, they're going on top of the specific number we're talking about. When we were talking about 23, that 5 went on top of the 3. All right, so now we're going to bring down that next number of 2. 4 will go into 32. How many times? Okay, 8. So 8 is going to have to go on top of the 2. Guys, just make sure that decimal that's up on the roof is in the right place. Because remember when we raised it straight up. We're not like curly cueing it wherever we want it. It goes straight up. All right, 8 times 4 is 32. When we subtract, we get 0. Now, guys, we got 0 here. Is there anything else we need to bring down? Do I need to keep dividing this? No. So here's my answer. Raise your hand if you can tell me what type of decimal is this. What type of decimal is this? McKenna. It's a terminating decimal because it stopped. My division ended, so I'm done. It's terminating decimal. Questions about that? All right. All decimals are not going to be terminating, so let's look at these next examples to see what might happen in some other situations. All right, we only have 2 examples that we're going to do together today before you get started on your homework, all right? So, on number 1, remember the number that comes first is the one that goes in the house. So, I'm going to put 0.496. Remember that spacing out technique? Could that be beneficial here to space your numbers out a little extra? To make sure it's lining up? Absolutely. All right, and then my 1.2 is the one that's shut outside the door. All right, raise your hand if you can tell me. What should I do first here? Grace. Move the decimal. How many places are we moving it? Once. So I have to move it over once at the door, and that means I'm going to move it over once in the house. All right? Now what should I do, Locke? Raise the decimal. So we're going to raise the decimal up to that roof, all right? Raise it to the roof. Okay. All right, so now we're ready to start our division. Is my division any different?
No.
Regular algorithm here, guys. So I'm looking at the number 12. Can 12 go into 0? No. If you want to write a 0 up there, you can. If you want to put a little X there to know that you tried 0, you can. Will 12 go into 0, 4, which is just 4? Can 12 go into 4? No. Again, you can put a 0, especially since it's the number right in front of the decimal. This would probably be a good place to put a 0. All right, or you can put that little X there. Now remember, you can't always use X's if it's in between something. We are going to need zeros in some places, okay? So this would probably be a place that I would go, okay, that's in front of the decimal. I can put a 0 there. All right, so now I'm looking at 12, 0, 4, and 9. So 49. How many times can 12 go into 49? Jacob? 12 times 2 would give me 24. Can we get closer to 49 than 24? 4. So we're going to do 4. Because 4 times 12 is 48. So when I subtract, I get 1. And I'm going to bring down a 6. All right. How many times will 12 go into 16? Once. Okay. So I'm putting that 1 on top of the 6 from 16. 1 times 12 is 12. 1 times 12 is 12. And then when I subtract, I get a 4. All right? Now, in this case, did we end up with 0? No. Now, normally, this is where we would make it a fraction. But remember, can fractions and decimals coexist?
No.
No. Like, they would take over planet Earth. All right? Math would fall apart, which means everything else would fall apart because math is a part of everything.
Not really.
All right? Everything, music, art, all of that has math fundamental backgrounds in it, okay? So, we're going to go ahead, guys. We can't make this a fraction because we don't want them to get together. Logan, do you know what we're going to need to do?
Yes.
What do we need to do?
So we're gonna have to make that 4 into like 40.
Yeah, so what we're going to do, guys, so remember with decimals, the cool thing about decimals, if I add zeros after a number, does it change anything about the place value of that number? No. So we can add a 0 up here next to the 6, and now do I have another number I can bring down? Yes. Now, guys, here's my little stipulation. I don't want you just putting a 0 next to that 4. I want it added to the decimal and brought down, because that's actually what's happening, okay? So now I'm going to divide again. Please stop tapping. Thank you. How many times will 12 go into 40? Logan?
Only 3 times.
Only 3 times.
4.
So 3 times 12 is 36. And when I subtract, I get 4. All right? Now, guys, this, I want you to look. The 4 that I got before came from 16 minus 12, right? This 4 came from 40 minus 36. So has the problem actually repeated yet? No, that was 16 minus 12. This is 40 minus 36. We actually need to keep going here, okay? I want us to add another 0 and bring it down. So now we're starting to see that problem repeat. How many times will 12 go into 40? 3 times. 3 times 12? 36. And when I subtract, I get 4. All right, look right here at what I'm circling. Do y'all see how now we actually have the same problem repeat? Okay. Until we see that problem repeat, it might just be a coincidence that we're getting that same number. All right, we're going to look at 1 in just a minute. Or let's look up here. Let's look up here. We got a 1 and then we got a 1, right? Did that mean something was a repeating decimal? No. So just because I get 2 3s in a row, or I subtract and I get 2 4s in a row, that doesn't necessarily mean it's repeating, okay? Once we've seen this happen twice, then I can say it's repeating. Are we okay with that? All right, and then again, we know it's repeating because I'm going to keep bringing down zeros every single time. All right, so the way that we're going to write this answer, you can put your 0 in front, or you can just write 0.413. Do I need to include a bunch of 3s? Now, what can I do to show that that 3 is going to keep going? Hannah? We're going to put a line on top of it. Guys, that is called bar notation because math people are super creative. All right, so right here, that's called bar notation because you're putting a bar over the number that repeats. Yes?
Why is it such a long word? Why can't I just put, like,
Because notation is a certain way, like notation isn't a math word. Notation is just a certain way of writing something. All right, it's a certain way of shortening things, which they have a long word to tell you how to shorten stuff. The bar is just what we're using to write that in. Okay. All right.
I'm pretty sure that, like, if you were to do, like, 313 or something, you could do something notation, and it would be like, and it would show 3 times 100 in parentheses, and then times.
Absolutely, yes. All right. So on number 2, what number is going in the house here? 45 is going in the house. And that 0.004 is going at the door. Now this one looks a little weird. Normally we would probably think, oh, 45 doesn't have a decimal. I'm going to put that at the door. Do we get to choose where to put things in division? No, every single time. That first number you don't get to pick. It's going in the house if you want to get the right answer. That first number has to go where? In the house if we want to get the right answer. All right. So from here, I have decimals at the door. Can I have decimals in my divisor? No. So I've got to move it over 1, 2, 3 spaces. If I move it on the outside, we got to do it on the inside. But remember, on the inside, it's just the number 45. There's not a decimal there right now. Dalton, what do I need to do? Add zeros, yes. But first, there's something else I got to add. Hannah?
You can put a decimal behind it and then put, like, as many zeros.
Make it match, yes. So, like, right here, I have 45 with a decimal at the end. Because remember, it's 45, period. That's the end of the number. It has a decimal there. Now, normally, do I have to say 45, period? That's the end of it. No. Normally, it's just like, okay, it's 45. But in this case, since we're talking about decimals, we do need to know that is 45, period, the end. Now, do I have a decimal? I can move 3 places. Yeah, so now we're going to add 1, 2, 3 spaces to that. And in those empty spaces, we're going to fill in zeros. And I'm going to make my line a little bit longer. Because what do I still have to do with that decimal? Even though it's the end of all those zeros, I've got to raise it up. Tanner, do you have a question? Yes, sir.
On our homework, do we have to show you that we're moving it, or can we just write it the right way?
As long as I can see where that decimal is in the end, yes. I want to see where it is in the beginning and then where it is in the end when you move it. Does that make sense? So if you want to do like one kind of movement, that's fine. But I do kind of want to see the movement happening. But you don't have to do like skip, skip, skip. All right. So now what number am I actually dividing here? Just the number 4, where this problem started out like crazy hard looking. Now we're just dividing a 4. How many times will 4 go into 4? Once. 1 times 4 is 4. When I subtract, I get 0. Bring down the 5. 4 will go into 5. How many times? 1. 1 times 4 is 4. When I subtract, I get 1. Bring down a 0. 4 will go into 10. 2 times. It's going above the 0 that I brought down, not just any 0. All right, 2 times 4 is 8. Subtract, we get 2. Bring down the next 0. So now I'm looking at 4 will go into 20. 5 times. 5 times 4 is 20. When I subtract, I get 0. So this is really tempting to stop here and say, okay, I'm done. How can I look at this and know, nope, we're not done. What can I look at this and tell? Taylor? Yeah, do y'all see where I have this gap? Does 0 have anything on top? No. So are we done yet? No, we got to bring it down. 4 will go into 0. 0 times. Guys, is that a 0 that I have to write in? Yes, you do not have an option. That one has to be there. 0 times 4, 0. So my answer is actually 11,250 here. Tanner, question? It was right here. I brought it up right here. Remember, we moved it down to the end, so it's actually right there. Now you'll notice, let's talk about that decimal that we did bring up. Did I circle that in my box? Not really. If you did, it's not a big deal. All right, but remember, now it's just 11,250. We know there's a decimal at the end of the whole number, but do we have to write it in? No. All right. So what I want us to do, guys, is we're going to get out a piece of paper to set up. This is how I want to see, like when we have homework from the textbook, that's how I want to see your page set up. You're going to put your name and the date, just like we did on our notes, and number 11, just like we did on our notes. The difference is, over here on the top line, you're going to write, our homework is in your textbook on page 58. You're going to do numbers 10 through 21. And you do need to write that on the top line. All right? So when you get home, you don't even have to look at Remind to remember where your homework was. You've already written it on your paper. All right? Now remember, our textbooks, where should they be? At home. Aaron, we signed these out last week while you were out, and I have one signed out for you already, so you'll come and get yours. Since we're in here and our textbooks are at home, I'm going to pass out a sheet. I only have 30 copies, so this sheet is mine. Can you write on it? No. It is not for you to keep. It is just 30 so that I'll have something for y'all to look at in here because we don't have enough textbooks.